Hey Mech 312, someone hung a picture of Keanu Reeves attached to a piece of cardboard in my room, but before I called the police, there's something interesting I noticed. If I displace this pendulum, per se, from its equilibrium position, it oscillates back and forth, kind of like a spring mass system. And as I go further, there are greater oscillations, greater amplitudes. See, in a spring system, the stiffness of the spring causes a load to be applied towards the equilibrium position, and as that displacement increases, the load increases. But in a pendulum, there's only one force acting on it that's constant: gravity. However, as the displacement of the angle increases in a pendulum, the force of gravity, more percentages of it are getting added along the arc that the pendulum's traveling and pushing it back towards the equilibrium center, to the point where at 90 degrees, the full force of gravity is pushing it back towards that initial resting point. Now, unfortunately, this sort of a pendulum is dampened by air resistance and friction, but just like an undamped spring mass system, this thing could oscillate forever, given that no energy was added or taken away from the system. And in fact, we can model this motion with the same sinusoidal equations we came up with for spring mass systems. Now that's truly breathtaking.